Epstein-Barr virus, and influenza virus. So again, this is Journal of Clinical Investigation, 2001. In 2005, I published a review article on this topic discussing the nutritional and botanical inhibition of nf-kappab, which is still considered the major intracellular amplifier of the inflammatory cascade. You can access and download this article for free from my page on academia.edu. Let's look at another article that confirms many of these ideas. This article discusses nf-kappab as a target for anti-HIV chemotherapy. You can see this was published in 2003, discussing nf-kappab as a lymphoid-specific transcription factor. Transcription factors are basically molecules that translocate typically from the cytoplasm into the nucleus to promote gene expression of certain gene patterns, and in this case, nf-kappab activates a pattern of gene expression associated with infection and inflammatory disorders. So again, nf-kappab is a transcription factor critical to the expression of inflammation-related genes. nf-kappab, as you can see here, plays a major role in the regulation of HIV gene expression. Upon activation, nf-kappab is released from the inhibitor kappab protein, moves into the nucleus, binds to its sites on the HIV long terminal repeat to start transcription of the integrated HIV genome. Combined drug therapy has presented the problem of resistance, and that is resistance by the virus because the virus mutates to evade restriction by antiviral drugs. The authors go on to say, however, targeting nf-kappab for the suppression of the virus does not present the problem of viral resistance because nf-kappab is a component of the human biological machinery, so it doesn't have the same ability to mutate, nor would it have that ability in the same way that viruses do. And that's because nf-kappab is a normal part of the human immune system and is not subject to mutations as is the virus. So every year, for example, you hear about influenza virus mutation. That's why they keep pushing a new flu vaccine every year, because the virus mutates. Well, if we were to change our focus, and instead of focusing in on the virus itself, if we were to focus in on the machinery that replicates that virus, a large part of which is this nf-kappab pathway, if we focus on what we can control, which is the nf-kappab pathway, then we wouldn't have to concern ourselves every year with viral mutation. And let's look at one more article now that states the same. So this abstract from this article in 1992 actually summarizes a few things I've already said and also a few things I'm about to say. So I'll take a moment to read you some of the highlights. N-acetylcysteine, or NAC, or acetylcysteine blocks HIV expression in chronic and acute infection models. They observed an antiviral effect of NAC, which they stated is due to the inhibition of viral stimulation of reactive oxygen species, which are produced in response to inflammatory cytokines. And note what they say toward the bottom of this page. NAC is different than many other antiviral drugs in that it inhibits host-mediated stimulation of viral replication. That's that nf-kappab pathway that I just mentioned, arising in a normal immune response. In addition, NAC inhibits the action of inflammatory cytokines, which may mediate cachexia, or muscle wasting, which I also already mentioned, and it may therefore alleviate the wasting that accompanies late stages of AIDS. So that's exactly what I had already stated. Now let's go on to look at a few more mechanisms before we get into the clinical studies. So again, this particular article alluded to the antiviral effect of NAC being the nf-kappab pathway and also reducing free radical formation, and you'll see that echoed in this more recent article from 2016. Title of this article from Current Zoology is Oxidative Stress Favors Herpes Virus Infection in Vertebrates. So you'll see here from the excerpt that viral infections create a vicious cycle. Viral infections induce the production of more free radicals, but those same free radicals then support additional viral replication. So you see a vicious cycle. Virus infections cause free radicals promote viral replication. So if you can break that cycle with antioxidant therapy, such as NAC, then you can break the cycle of viral replication. And in this case, they're specifically talking about herpes virus infections. But of course, herpes viruses are a huge family of different viruses, not simply herpes simplex 1 and herpes simplex 2, but also the zoster virus as well as others. So now we're going to start getting into the human clinical research, and in this case I'm going to focus in on human clinical trials and review articles published in clinical medicine journals. So let's start with this one from Advances in Pharmacology. This was actually a textbook, Advances in Pharmacology in 1997.